Alright, this is take 4 of trying to showcase my adder. Wait, I have to clear everything first. Let me just clear those registers, clear these, and these, and then lastly the adder. Yep. Okay. So, here's what we're going to do. We're going to do just some simple math that I hopefully don't mess up with the coding. What we're going to do is we're going to set R0 equal to 86, R1 is going to be 22, and then we're going to set R0 equal to R0 plus R1. That should give us a value of 108. We're going to set R1 equal to 63, and then we're going to set it to negative 63. And then we're going to store the sum of R0 and R1 into R1. And that should give us a final value of 45. So we're basically 86 plus 22 equals 108 minus 63 equals 45. So here's the code. I've written it in LC3. So we're going to first store 86 into R0 and 22 into R1. And then we're going to add both of those and store it into R0. And then we're going to AND R1 to clear it. And then store 63 into R1. We're going to NOT it. We're going to basically flip the bits and add 1. That'll get us the 2's complement. And then we store that sum into R1. Alright, let's give it a shot. So R0, R0, and decimal 86, which is going to be 0, 1, 1, 0, 1, 0, 1. We'll add that. Alright, there it's cleared. And we can hear it going. That should be our first one. That should be a 0 and a 0, and there's a 1. 1, 0, 1, 0, 1. Perfect. And then all that's going to be stored into the register. It's going to be very loud. Ooh. Yep. 0, 1, 1, 0, 1, 0, 1, 0. That was backwards, but okay. And then next, R1, R1, and 22, which I believe I just flipped this off. Let me just make sure. 0, 1, 1, 0, 1. Perfect. So this should be stored into R1. I did select it right. Yes, okay, perfect. Let it clear the display. There it goes. So 0, 1, yep. 1, 0, 1, and that should be it. It's going to take a while to do the last 3, but I'm just going to fly in here preemptively to make sure that it stores properly. So that should be in this bits right here. So looks like it did. Yeah, stored properly. Perfect. Alright. Step 2 complete. Let's see. And then we add R0 and R1, store to R0. So store to R0, add R1 and R0, and make sure to switch this to register. Clear this so I don't fuck up. Make sure it's right. R1, R0, R1, R0, R0, R1, R0. Perfect. Alright. So this should give us a value of 001101110. 001101110. Let it clear. Come on now. There we go. 0, 0, 1. Yes. 1. Perfect. Should be a 0. Okay. 1, 1. Cool. So that is going to be stored into R0. And then just make sure it's all done. Storing R0 should have our value 0, 0, 1, 1, 0, 1, 1, 0. Okay. Almost done with loading. Almost halfway done. How about that? All right. R1, and we're not, or we're anding, right? Yeah, we're anding. So and R1. Oh wait, no, R7 and R1. So this should just store 0 into R1. I'm hoping that works. Let me just check and see that my and is wired up properly. So I have and selected. And yeah, that should work. Hopefully. Uh-oh. That could be a problem. Okay. Not sure why that... Why is that one powered? Why do these have... Oh, I guess it's already doing the and. But why is that powered? Yeah, okay. Fair enough. Okay, well, that's something to check on, I guess. Another thing to troubleshoot. Hopefully this works. So we should just get all zeros. Oh no. It's all zeros, right? Into R1. Let's check R1. Hey, it works. Yes. Okay, so we have all zeros into R1. Perfect. Alright, so all zeros into R1. We're doing R1, R1, and 63. So R1, adding, R1, we're doing manual, and 63 is going to be 1, 2, 3, 4, 5, 6. Yep, that's 63. Make sure it's on manual. Yep, looks good. And that's all going into R1. Alright. So we should just get a bunch of ones. It's going to take a second. An easier way to do this would be to implement an OR gate for adding, like, or storing a value. It would just be a lot quicker, but I have yet to program an OR gate. So we're stuck with anding with 0 and then adding. Because OR would just do the same. It would just store the value, but it'd be a lot quicker than the adder, because the adder has to go through all the calculations. It's alright though, I don't mind waiting. Hopefully you don't mind either. So there we go, we got 6 ones, and it should be done in a second, and that should be stored into R1. Yes. So we have 63 in R1 and 108 in R0. So now we have to flip the bits in R1. So stored into R1, we're knotting R1, and that should give us 0, 0, 1, 1, 1, 1, 1, 1. Or wait, 1, 1, 0, 0, 0, 0, 0, 0. Yes, perfect. 1, 1, 0, 0, 0, 0, 0, 0. Heck yeah. Make sure it's stored into R1 properly. Yes, zeros and then ones at the end. Alright, so we're almost done getting 2's complement. Last thing we have to do is add 1. Add 1 and store it into R1. So R1, we're adding, store into R1. We're using manual. Make sure that's right. R1, add, R1, and manual 1. Cool, so we should get, oh, it cleared it, right. So 1, 1, all zeros, and then the last one's going to be a 1. There, it clears the register, or the display. 1, 0, 0, 0, 2 more zeros, 0, 0, and then this should be a 1, 1, perfect, 1. Alright, so now we have, this is negative 63, and that should get stored into R1. So 1, 4 zeros, 1, 1. Alright, almost there. So now, last step, add R1, R0, R1. So store into R1, we're adding R0, R1, register input. Let's check. R1, R0, R1. So store first one, second one, and register input looks good. So we're looking for a value of 0, 0, starting from the left, 0, 0, 1, 0, 0, 1, 1. Wait, did I read that right? 0, 0, 1, 0. So 0, 0, 1, 0, and then 0, 0, 1, 1. And that should give us 45. So starting from the right, there we go, it's cleared. 1, 0, 1, 1, 0, 1, 0, 0. Perfect. So, in all that time, we finally got our value of 45. We did all the steps correctly, and it was quite a task, but it worked. And the reason I liked this code is because it used all of the options that I have programmed, the add, and not. And yeah, I guess that's it. Thanks for watching.